Hello, I'm Dr. Taylor, and welcome to Dr. Taylor's Pedagogical Notes. We're going to start with whole number addition. We're going to take a look at from the concrete level all the way up to abstract with simple and straightforward connecting pedagogy that will help students build understanding. All right, let's get started. So on the first page of each one, it talks about how we're going to build up from concrete to abstract. It also offers you a link to my website where many other resources are available for teachers and coaching resources, pedagogy resources, differentiation resources, planning resources, discourse resources, etc. There's printable and electronic versions of a student's post-activity accountability form in case you want to use this as a flipped classroom or a take-home activity or an in-class activity with student accountability to make sure they actually engage in the process of looking at the slideshow. Or you can show them this video. It's up to you. All right, let's get started. Okay, starting at the concrete level, we can see that we have 3 and 5, and we're going to combine those things. If I have 3 oranges and 5 apples, and I combine them, how many pieces of fruit do I have? I want to contextualize my math problems. I don't want to do what's called naked math. I don't want to just put some numbers up there. What's 3 plus 5? Great, it's that. That isn't helping students understand. That they may memorize some facts and spit them out at you quickly, but when the numbers get bigger and the things get more difficult and the problem gets more hairy, the understanding that's missing causes them to give up. So if you want perseverance, creative problem solving, and understanding, I think discourse and pedagogy is the way to go. So first of all, we're going to use a manipulative for the student. They can have the colored squares in their desk. Up here on the slideshow, it's going to be symbolic, obviously, or graphical, I should say. But we're going to use the graphic to represent the manipulative that's on the desk. It could be anything. It could be candies. It could be anything. I've just got colored squares on the presentation. So I'm going to start with 3 because our first number is 3, right? Next, I'm going to look at 5 other objects because my second number is 5. Notice I took my 5 and I decomposed it into 1 and 1 and 1 and 1, etc. My 3 the same way, 1 and 1 and 1. Building into the student understanding that every number is a group of units pushed together into one pile that you could enumerate with a value, okay? I could have 3 things and 5 things. When I push them into a group, I've got the combination of 3 and 5 things. All right, so we're going to count these out, 1, 2, 3, and counting 4, 5, 6, 7, 8 things. Counting is a fine strategy. There's nothing wrong with it. Use the strategy that makes the most sense to you and build up to more advanced strategies. Using some of the strategies will help these students gain understanding and confidence and perseverance. 8. Now, I could also skip count, right? I could also regroup. Like, that's just an arbitrary grouping, right? If I put one of the squares up top, now the groups are like in groups of 4, and you can see that I have how many groups of 4, but I have 2 groups of 4. So I could, and since there's nothing left over top and bottom, they group together easily. I can go ahead and group independent little pairs or other size numbers. But I'm just going to go with pairs right now. Look, there's one pair. That's 2. That's what a pair is. So there's 1, 2 there. Then there's another set of 2 and another set of 2 and another set of 2. And this builds in the notion of skip counting. I can group them with pairs and skip count. 2, 4, 6, 8. Still coming to the 8 that I would have done if I'd have counted individually. So I first start counting individually and I build up to skip counting. I could skip count in higher numbers, but let's just stop right there for now. And let's go ahead and take a look at the graphical example. Now the graphical example is going to look very similar to this one because obviously I'm on a board. But what they would do is they would push their colored squares together and create little strips, right? Tape diagram or strip diagram, the Singapore math, right? This is a strip diagram that represents 3 units pushed together, which means they are a group of 3. So obviously this next thing will be a group of 5. Absolutely. Now with the strip diagram, I could arrange them in any order again, but it makes the most sense for me to organize them as the user in such a way that lets me figure out what the total value would be of those 2 numbers being combined. The most obvious way is to just put them in a great big line and I can just count right down the line. 1, 2, 3, 4, 5, 6, 7, until I get to 8. Okay? But I could also group them and skip count, right? There's my pairs. Remember how I did that before? So there's 2 and 4. I'm skip counting now. And 6 and 8. 8 total squares. Is that the only way I could group them to skip count? Will 3s work? Give it a shot. Push pause. Okay? Did 3 work? Were there any left over? Can I still do it, skip counting by 3s, and then add what's left over or subtract what's missing? Of course I can. Let's go with a more simple strategy for right now. This is the beginning. Let's group them into 4s. There's one group of 4, and there's another group of 4. So what is 4 and 4, right? I can skip count as I get more sophisticated in my understanding. 4 and 4 is again going to be 8. All right, so now let's go to symbolic. Symbolic will be a way where I could draw it on the paper that isn't necessarily a picture, but is symboly. So I'm going to use the symbol of a number line as a tool, right? This strategy of counting up has been the same, and skip counting has been the same. Different ways of showing that strategy is not a new strategy. Those are just different ways of presenting the same strategy. The strategy we're looking at now is counting up and skip counting, okay? So we must draw a number line for ourselves, but where does a number line begin? It can begin anywhere you want, but since I'm starting out with nothing and counting up 3 and 5 more, it makes sense to go ahead and start my number line at 0, but I can start it any way I want, okay? Now there's a lot of words that I just blasted by there while I'm talking to you, because if you were reading them without me, they would be necessary. But I just synopsized what they said, and you can go back to the slide presentation and look at it at your own pace over and over again to help you. Okay, so if I start at 0, I'm going to have to add some ticks, and I know that from my previous experience I've got around 8 ticks, but if I didn't know that, I would just put some ticks. What's the worst case scenario? Is I put too much, or I didn't have enough and I have to extend my line and put a few more. That's no big deal. Perfection isn't necessary, right? We're just shooting for understanding, and understanding will bring us to a point of excellence where we can do a problem regularly with competence. So let's take a look at what I can do. Look, I'm just taking steps. 1, 2, how many steps did I take there? 3. Why did I label the number line? Because 3 was one of the numerals we were looking at. 3 oranges. That represents 3 jumps. How many jumps will it take to go farther? When I add 5 jumps, 2, 3, 4, 5 jumps to it, where do I end up at? Well, 3 and 5 puts me at 8. Could I have skip counted as I jumped? Absolutely. Imagine taking 2 stairs up the staircase. Could I jump by 2s, and then 4 steps, and then 6 steps, and then 8 steps? I absolutely could. All right? I could also skip count by 4, but I'm not going to bother showing you that again. And finally, the abstract. The abstract is what we want to happen, where I look at a problem and I intellectualize it, and I see it in my head, and I do my strategy in my head, and I present an answer from my head. Now sometimes we got to take and write because the problems get long, but when I can think about a problem, rationalize it in my head, and explain it to the group, I've got to understand it. So the abstract would be just taking a look at how I might do this in my head. Well, I might say, look, I start at 3, and then I'm going to go up 5 so I can just count up. 1, 2, 3, 4, 5 times, and I end at 8. I can use my fingers, 3, 4, 5, 6, 7, 8. Okay, that was 5 numbers I counted up. Just like starting at 3, there's nothing magical. I could start at 5, right? And skip count up 3. 5, 6, 7, 8, right? So I could do that as well. All right. So what I want you to see, it doesn't matter which of the add-ins you start with. The sum will be 8. No matter how you do it, whether you skip count or whatever, whether you use manipulatives or symbols, or you just do it in your head. What's important is you have an understanding of what addition means so that you can expand upon that to build up to higher skills. Okay? And so the final page off just always ends in the same way, and it offers you those same links that were available in the beginning. All right? So this is Dr. Taylor telling you thank you, and I hope this helps, and I will see you on presentation 2, subtracting whole numbers.